AUTOSAR. Explained by Annette Kempf.
Thank you for joining today. We will have another look at AUTOSAR topics. We are looking at AUTOSAR Classic Platform within the Microcontroller Abstraction layer. And there, the topic today is Microcontroller Drivers. We will start first with an extract from the e-learning that you understand, like the overall context and what's where you are within the overall AUTOSAR architecture. And then we will go through detailed specifications in the second part. So the first part will be e-learning, and after the e-learning, I will be back to share further information.
The microcontroller abstraction layer is divided into 6 model groups, which group software modules of similar type. In this case, the software modules are internal drivers. A driver is a software module with direct access to peripherals. The internal peripheral devices are shown in the hardware layer. The module group microcontroller drivers consists of drivers for internal peripherals, like the general-purpose timer and the watchdog, as well as functions with direct microcontroller access, like the core test.
So I hope you enjoyed this introduction. Now we will have a look at the microcontroller drivers within the Classic platform. And for this, we will have a look at the AUTOSAR standard. So what you see right now here is the AUTOSAR page of the Classic platform. So here we are within standards, the Classic platform. A short introduction on the Classic platform, which we don't need, we saw. Currently, we have a release 23.11. 11 is for November because all the releases are in November, and 23 is for last year in November. Here you see the overview of the architecture. You probably, and also in the video, you saw the representation with the different layers. Here in this picture, you have a navigation directly to a set of specification and requirements documents. We said we'll have a look at the microcontroller drivers. In the overall context, the microcontroller is really the hardware, which is not part of the AUTOSAR standard, and the microcontroller drivers are belonging to the microcontroller abstraction layer. And with microcontroller drivers, you have a set of requirements and specifications which are defined in this area. So once you click, I opened here, you will see all the drivers. No, this is wrong. So we'll click again. You see the drivers which are belonging to the microcontroller drivers exactly in this part which we saw here from an architecture point of view. And what's part of a microcontroller drivers? You see here the different specifications. The first part is the specification of a core test, meaning that really the hardware is tested. And I will just go through on a general level right now. The GPT driver is it's the general purpose timer. It's used for on-chip timers. It's the configuration of the timer channels, start and stop of timers. It supports one-shot and continuous operation mode, and lots of other things. Yeah. The next part is the MCU. MCU stands for microcontroller unit, and it's responsible for all the configuration, like configuration of a clock, of reset, of power mode settings, centralized hardware, resource reservation, and so on. And it's also providing services for the other drivers. And the watchdog driver, in short, often abbreviated VDG, is the watchdog, which you know. Before going into the specifications, I would like to have a look. I just chose the Infineon page because all these microcontroller drivers are a part of the MCAL, and usually the MCAL is provided by the chip producers. And for example, you have here a picture of the MCAL from Infineon for the AUREX microcontroller, and they chose the same representation as within AUTOSAR. So you find which drivers of the MCAL are in which layers and which are connected to which set of specifications. And here you see that there is a set of drivers which is connected to the microcontroller drivers, MCU, watchdog timer, and in general purpose timer. This is their representation. Yeah. Now we go back to the specification. Specification of a core test. Yeah, you can just open it, and each specification has a lot of history. Yeah. And a disclaimer, like always, and then the real content is starting. Introduction and functional overview. I would always recommend to read because it's giving you a general understanding what this driver is doing. Yeah. So this specification specifies the functionality, API, the interface, and the configuration of this module called core test driver. And it's applicable to all drivers and all cores, regardless if the driver is executing during power on situation or during ECU application runtime. So it's for power on and for runtime. This driver provides services for configuring, starting, polling, terminating, and notifying the application about the core test result. And it also provides services returning test results. And I think it's important, it's checking the general purpose registers of ALU. And it's that every tested core functionality has been accessed for testing purposes. I consider this as very important, and it's usually done in the startup. Yeah, before you start an application, just imagine that your hardware is not working. Yeah. So you can access this driver directly because it's like the starting point, and it's so it doesn't need any other immediate software layers, and it's located, as we said before, here in the microcontroller abstraction layer, and in specific, it's part of the microcontroller drivers. Then, of course, you always have acronyms, you have related specifications and so on, which is short here because it's one of the bases. Yeah. And lots of details. And then finally, we get to requirements traceability. And then finally, we get to the functional specification in itself. And here you see it's for testing all CPU registers, interrupt controller, exception detection test. So it's really all these safety functionalities. It's testing if ALU is working. yeah, all these different aspects which you need to understand or to be sure that your microcontroller is work, like cache controller test. You have, which is important, you can test in the background and in the foreground. Why is this the case? Sometimes testing everything is taking a long time. And if you consider you have a reset and you need to test, for example, all your ROM check, then this might not be completed fast enough. So this can run also in the background. Yeah. This was just like a short insight. I think the specification can be read by yourself, yeah, also in detail. So the testing the microcontroller with this microcontroller core test is part of a microcontroller drivers. Then we have a next one. I would not go alphabetically. I would now go to the MCU driver, so meaning the microcontroller unit driver. The microcontroller unit driver, it's the same for the structure, scroll, yeah. And here you have the functional overview. So it's the functionality for the microcontroller unit driver. And this microcontroller unit driver provides services for basic microcontroller initialization, power down functionality, which is also very important, reset and microcontroller specific functions, which are required by other MCAL software modules. The initialization services allow a flexible and application-related MCU initialization in addition to the startup code. The startup code is very microcontroller unit specific. Yeah? The provided startup code description in this document is just for guidance. So we're really lucky that these specific applications are now done by the chip producers. For example, Infineon, NXP, and others. When I started, this was not the case. You had to take care of this yourself. Yeah? So you can rely on this. The features, MCU clock, PLL, the clock prescalers, and MCU clock distribution. And it's the initialization of different RAM sections. Then you can activate the reduced power modes via this, and also the activation of a microcontroller reset. And provides a service to get a reset reason from hardware. And this is also very great to know, because I remember in the past when you had resets and you didn't know why it's resetting, then you have a hard time debugging and finding the root cause. So I would say in this case, of course, the interfaces are important. Yeah. So there are quite a lot of dependencies to other modules, like before with the test. We didn't have lots of interfaces, but the microcontroller unit specification has lots of interfaces, and it's more or less abstracting the microcontroller for you. So most likely you will work on the interfaces and not on the microcontroller unit yourself. Yeah? For example, it has the connection to the startup code, and it has the connection to all the MCAL drivers where it's providing services for or APIs for. Yeah? I wouldn't like to, it's like a general introduction. I cannot give all the details on the driver. I think depending on which of the MCAL drivers you are working, you need to check what your interfaces to the MCU are. Okay, and then we have GPT, the general purpose timer. I would say this is also something very, very important and giving you guidance and structure. And it's also a driver where many other drivers are relying on. The same has history and a disclaimer. And then we have introduction and functional overview. So what is the GPT for? The GPT driver is part of a microcontroller abstraction layer and part in this structure of microcontroller drivers, as we are discussing today. And it initializes and controls the internal general purpose timers, GPT of a microcontroller. So it's very, very microcontroller dependent as well. And the services include starting and stopping hardware timers, getting timer values, controlling time-triggered interrupt notifications, if the hardware is supporting this, and controlling time-triggered wake-up interrupts, the same if the hardware is supporting this. What's also important to know about the timers, and this is a very, very important issue, is often these timers are shared. So you have pins which you can configure as digital output, digital input, and for example, as a PWM. And these there may be 3 pins or 2 pins which are sharing the same timer. So meaning that you can, for example, if you have 3 pins which are sharing the same timer, then you can only have one pin which is using the timer where it's assigned to. So if you want to have, for example, 2 PWM outputs, then this wouldn't work. This is something you should have a close look at and also review with your hardware guys, because if they are not doing the pinout correctly and considering these constraints of a timer, you might end up not being able to provide the software which is planned because the hardware configuration or pinout is not taking into account this issue. So this is something where you really need to know what's happening there, and you need to check how the configuration has to be done. But nevertheless, not all hardware timers must be controlled by the GPT module, so making it even more complicated. Some timers may be controlled by the AUTOSAR operating system or by complex drivers directly. And especially complex drivers is an issue where we'll discuss later in a separate meeting, where you have the problem that you're interfering with other drivers, and you need a lot of understanding of the whole basic software of AUTOSAR. Not everything, but a lot, especially the microcontroller dependent part. So microcontroller abstraction layer, deep know-how you will require for complex drivers, and you will have to see how the timers are distributed and other resources that you handle it correctly. Besides this possibility to continue individual driver channels with individual properties, so-called GPT pre-dev timers are defined. These timers have predefined tick durations and predefined number of bits, so they can be used. And this the GPT driver only generates time bases. Further time-based functionality on driver level is covered by other MCAL modules, And I said, as I mentioned before, as an example, the PWM driver, yeah, for pulse width modulation requires a timer because it needs to switch the level. And the same is for if you have the input which you are capturing, you need to know when you have the flank level changing, at which time this happened, so that you can analyze the data later on. And the same applies also for the output compare unit, that you need the timer base for this. Same, I would not go into the complete detail because you have to read all the details, how it's specified and so on. Yeah. And the last one I want to have a short look at is the watchdog timer. So the watchdog timer is also part of the microcontroller drivers directly. And the specification is given here. Not so many changes in the past. Yeah? The same structure of a document. You need to scroll a lot until you find the first part. Yeah? So this is the specification on the module called watchdog timer, and it's often abbreviated with VDG. So it's important that like the watchdog has to have the same API if it's an internal or an external watchdog driver. And yeah, it's monitoring the normal watchdog functionality, that your microcontroller is alive and that everything is working. Because if you get stuck, yeah, if you have a deadlock, then it's important that you find out and that you can actively trigger a reset. Yeah. So I will not go into a watchdog timer in detail, but this is what we have as part of this microcontroller drivers, which is part of a microcontroller abstraction layer. And all together, let's have a look at the overview again. All together, we have it's structured into 6 areas. And so this is all part of microcontroller abstraction layer. And today we had a short look at these microcontroller drivers. I hope you enjoyed it and it helps you to understand, especially the small hints in between. And I hope to see you again for the next part, the memory drivers. Thank you. Thank you for watching and see you again. Bye.
If you want to learn more about AUTOSAR and other interesting topics, go to embedded-academy.com.